Hello everyone. Let's get started again. So here we are discussing. So in this video series, we discuss continuum mechanics. So I think last video series I stopped at this point where we discussed the summation convention. So today I'm going to continue from that. So we have to discuss the vector product. Again, this is just the definition. From this, you might have studied the different definition for scalar product and vector product. Actually, not different definition. You also studied this way. You define IJK, then IJK property you define. Like I explained to you, it is mutually perpendicular each other. Therefore, dot product is 0. Dot product between them is 0. Then cross product between them, it will give the third vector. The same thing we are going to discuss here. So those part also you studied as a definition. Same thing we are doing here. So only thing we follow our convention, sign convention. That's the only difference we are discussing here. So you have, that means in your mathematics class, you didn't have a chance to discuss this Kronecker delta and everything, right? But this part we are introducing here. These are some new parts here, um, uh, apart from what you studied in your mathematics course. Okay. Since we discussed already the Kronecker delta, so let me connect this Kronecker delta with summation conventions. So that means the fourth point, so which I am going to discuss here. Let's say if it is delta II. Again, I told you if any index, if repeats more than once, there's a summation convention is there, right? So you have to think the summation convention. That means term plus, like this way, first term, second term, third, right? So again, in every index here, move 1 to 3. Here also I goes from 1 to 3. 1, 2, 3. So therefore, every time I don't repeat this one again, because this is, you must remember, it goes 1 to 3 every time. So therefore, here summation convention is there. So therefore, delta 1, 1, delta 2, 2, and delta 3, 3. So this is the answer for this one. Okay. So, but you know already, delta 1, 1, delta 2, 2, and delta 3, 3, we discussed, right? Delta 1, 1 is 1, 2, 2 also 1, 3, 3 also 1, right? So therefore, this is 1 plus 1 plus 1. The answer is 3. Wherever you find delta II, you will get the answer 3. This is the another properties of convention and the Kronecker delta, Kronecker delta, right? So now let's move to the fifth one. Fifth one here I'm going to discuss. When you multiply Kronecker delta again. Okay. Right. So here, delta ij multiplied by delta ij. So in this case, again, we discuss before doing any simplification, first you have to judge whether it is scalar, vector, or tensor. So for example, I repeated 2 times, j repeated 2 times. So we have only repeated index here. So therefore, this is not a vector. This is not a tensor. This is the scalar. If you don't have any free index, that is the scalar. Scalar means finally you must get one number. For example, in our previous case, delta II, here I is a repeated index. No free index. Therefore, this is a scalar. That's what we end up with one number, 3. So this, for this case also, we should get one number as an answer. Okay. So let's discuss here. But actually, you can do practice in your own. I and j both goes 1 to 3. So for example, the first part I will explain here. So now again I and j, it's repeated more than once. Therefore, summation convention will be there. Because I told you, when you have repeated index, there's a summation convention behind that. So here also, for I, you have to apply summation convention one times, then j also another time. Okay. So now, first, I'm going to apply for I. I'm going to substitute I 1 to 3. Okay. So when I substitute I have to apply summation convention because I repeated more than once. So therefore, delta 1j. I did not substitute for j now. First, only I substitute I 1 to 3. Now again, I am substituting I equal to. I have to put summation sign. Why? Because repeated summation convention is there, right? So now I have to substitute I equal to 2j, 2j. Plus, now I equal 3, 3j, 3j. Right? So now I have done for I. Now I am going to do the same thing for j now. Right? Okay. So again, j, I have to substitute 1 to 3 because j is repeated index here. I have to apply summation convention. So that means delta 1j. So now I have to substitute j equal 1, right? Delta 1, delta 1, 1 plus now j equal to delta 1, 2, delta 1, 2. Now j equal 3, delta 1, 3, delta 1, 3. Again, these three terms only for first part. We have written here. So now after completing this question, you understand the benefit of index notation. Okay. So these all process we combine with just two terms, right? These all terms, right? So this first part only I have written for the first term, right? Similarly, now I'm going to write the second one. So again, j here 1 to 3, right? 2, 1, then 2, 2 plus 2, 3, 2, 3. Okay. So now this part for second term. Then now plus. Now third one, right? Now j 1 to 3, right? Third 3, 1, 3, 2. 3, sorry, 3, 1, 3, 1, right? J equal 1, right? Okay. 3, 2, 3, 3, 3, 3. That's all. How many terms here, right? 2, 4, 6, 8, 10. You see, these 10 terms, rather than writing these long expressions, we just write simply like this. So this is the benefit of index notation. But here only 10 terms. You will get some places, you will get 89, 81, even sometimes more than 100 terms. Everything you can write as a simple index notation. Okay. So now let's find out the values. You could remember the delta values. When I and j is not equal 0, I and j are equal 1. So here you can see I and j as equal. They have, this is also 1, this is also 1. 1 multiplied by 1. So this part, I and j are different. Therefore, these are 0. I and j are different, 0. Here, I and j are different, 0. Again, here, I and j are same, 1 and 1. Here, I and j different, 0, 0. I and j different, 0, 0. Here also 0, 0. Because I and j different. Finally, I and j same, 1. Then finally, what is the answer get? 1 plus 1 plus 1. Again, we get 3. right? Okay. So now I'm going to give you the shortcut. So we don't have time. Every time we don't need to do this one. Then if you want to do this expansion every time, why do you want to follow the index notation? Okay. So what is the shortcut? Shortcut is this one. Delta ij multiply by delta ij. Now what you have to do, this is one of the another properties of Kronecker delta. You have to select the common notation between these two. Let's say I am selecting j because j is repeated. Now what I have to do, first I will write delta, I write another index I. Now what I have to do, this is the properties of Kronecker delta. This j I have to replace by another index I. That's all. So this is the shortcut we are using here. Delta ij multiplied by delta ij just picked one index, one repeated index, replaced with others. For example, one other person, he can do this for this one, he can write this way. Delta. So what one person can do, he can pick I, keep j. So therefore you will keep j here. So now you pick the I, you replace with another index. That means you replace with j. Okay. So you can write this way or this way. In both cases, delta II already we discussed, that is 3. Similarly, I told you these index are dummy. You can replace them with anything. Delta II mean delta JJ, delta MM, delta PP, everything is 3, right? So this one also 3, this one also 3. If you move either way, you will end up with the answer 3. Okay. Right. Okay. So I hope this is clear, right? This is the next one, right? Number 5. So now I will move on number 6. So what is number 6? Let's apply these properties further. Let's say I will write like this: AI delta ij. So what is the answer for this? Again, before doing any simplification, just try to understand what is this quantity. Here you can see I repeated index, j is a free index. So therefore this is a vector because you have one free index here. So now I am going to apply the properties what we have discussed here. So that means I is repeated here. So therefore what I have to do, now these are the properties of Kronecker delta. Write A, write A. Now this I is there. Now what is Kronecker delta property says? I, you can replace it with another index. Here I is a common one. Another index, what is that? J. The answer you will get J. You know, Aj is a vector, right? Because now free index. We discussed already how to write a vector AI. Okay. So here, this is a vector. So finally, we get the answer Aj. It's a vector. Then again, it's kind of a practice I am telling you. If you want to understand this one further, you can expand this one using my approach. If you expand this one, you will end up with a vector. That means you will end up with A1, A2, A3. So, sorry, you will end up with capital A1, right? A1, A2, you will end up with this one. Again, I am telling you. Here, summation convention only applicable for I because I is the one repeating. J, no summation convention, right? You cannot write A1 plus A2 plus A3 because J is a free index. Summation convention applicable only for the repeated index, right? Okay. So finally, you will get three different equations, right? Not a single equation. So that is again, you will get the vector. Just try yourself, okay? It's kind of a practice for your case. Okay, I don't want to discuss everything here. Right. So this is the seventh one, right? Do I want to discuss anything? Okay. Okay, I think there are some other parts coming in my mind, but we can discuss that is later, right? Okay, for the time being, these things are enough. Yeah. Okay. So let's move to the next one. We are going to discuss here vector product. What is vector product? One vector, another vector. Now we are going to put cross multiplication. Another word, cross product, right? Why we called this one as a vector product? Because the answer you will get vector, not a scalar. In dot product, you get scalar. Here, your final answer also vector. Okay, right. Now again, I'll come to our definition. So now the definition is the cross product between our base vector. So what is base vector? E1 cross E2. Similarly, E2 cross E3. Again, these are the definition. E3 cross E1. Okay. The same thing. You can write it this way, right? Okay. I'll put another column this side. Okay. So now here, I'm going to change the order, right? Instead of 1, 2, 2, 1. 2, 3, 3, 2. 3, 1, 1, 3. Also, we have to discuss the same, right? If you multiply one base vector with itself. Okay. Similarly, if you switch also, you will get one, right? Okay, you can switch it. But in that case, it's same, right? Again, E1, E1. If you switch also, you'll write E1, E1 again, right? So therefore, switching order not applicable for last one, right? Because you will end up with the same thing again, right? Okay. So this is again the things you studied in maths, right? IJK, that definition. If you multiply I into J, you will get K, right? Third vector. The same thing here. You will get E3 here. Then here E1. The vector you don't have here, right? 3, 1 is there, therefore E2. Okay. Again, this is following our right hand rule. E1 is actually the x vector, right? So let me draw our, okay, let me go to our this one, right? Okay. So now E1, E2, you will get E3, right? E2, I align with E2 direction, E3, E1. Now E3, E1, I'll get E2, right? So now if I change the order, instead of E1 cross E2, if I change E2 cross E1, now I have to align with along E2 and E1, right? Now only things, the E3 direction change, right? Instead of plus X3 direction, now I am getting minus X3 direction. So therefore, when I switch the order, the sign will change, right? That's an important thing you must notice, right? E3 means here you will get minus E3. Here minus E1 minus E2. Okay. Again, this is we discussed for dot products, scalar products, you get 1, right? Here, because of it is perpendicular to each other, this is by definition, we will get 0. Again, this is a vector, 0 vector. Okay, so this is the definition of the cross product. Okay, now, so now like we define the symbols, right? Like Kronecker delta. Here we combine these all findings into single symbols that is called permutation symbol. Okay, permutation symbol. Let me check what is the notation if I want to use here. Okay, I'll use this notation, right? Permutation symbol, we write like this. I, J, I, J, K into E, K. Right? So actually, permutation symbol is this one. Okay, this is the permutation symbol, right? So we use this is permutation symbol. Okay, this is the permutation symbol. Actually, that is IJK. Right? Now, I'm going to define cross product. Then how can I combine? The first things, okay, the first part. Let's combine this one, right? If I write EI cross EJ, so I will get another vector, right? So that means E1, E2 mean I'll get another vector, E3. Okay. So now here I have to get one constant, right? I'll put K. Why I'm putting K here? You see that constant is +1 here, -1 here, 0 here, right? Okay. So now the K, how are I going to define the K? The first one, 1, 2, 2, 3, 3, 1. That means if it is follow a certain order, let's say 1, 2, 3, 1, 2, 3, 1, 2, 3. This order. That means 1, 2, 3, 2, 3, 1, 3, 1, 2. Anything in this order, so I can say this way, right? 1, 2, 3, clockwise, right? So not clockwise, clockwise, right? Okay. In clockwise order, I am getting K is 1. Similarly, the opposite, that means 3, 2, 1, 3, 2, 1, 3, 2, 1. That means same thing now, counterclockwise order, right? 1, 2, 3, order is other way. So in this case, my answer is -1. Other than this, right? 1, 1, anything is repeated, right? So that is 0, right? For other case. Okay. So this is actually the definition of IJK. So IJK, when IJK, IJ and K, when it follows in this way, this order, IJK is +1, right? When this one follows the opposite order, the answer is -1. Any other case, it is 0. So that is the definition of this epsilon IJK. So now I'm going to write this one here, right? So EI cross product with EJ. How can I write this one? Epsilon IJK EK. So this is the answer. Okay. So this is the definition of index notation of cross product, that means vector product. Okay. So here, the two things you must remember, this is the index notation of cross product, dot product, EI dot with EJ. This is already we discussed, delta IJ. Okay, right. I think this is the right point to stop this video. Then I will continue the next video. We define the base vectors and its properties. Then also we introduce Kronecker delta and permutation simple. Now we will expand our discussion to further. Another vector, any vector, not if it is not base vector, how can you define any vector? Then how can you move this one? Then expand this one to the tensor, right? So that's what we are going to discuss in next our future videos, right? Okay, let me stop at this point.